Hello, this is Dr. Brown. There was a homework problem that a student asked me about, and I worked it, and I thought it was interesting enough to share a video with the rest of the class. The problem happens to be in section 3.4. The number is 3.4.35T, and the problem deals with the position, the velocity, the speed, and acceleration of a particle or an object. Now, you already have seen in the videos that the velocity of an object is going to be the first derivative of the position. The acceleration will be the first derivative of the velocity, which will be the second derivative of the position. The speed is the absolute value of velocity. Speed is always positive. Now, the object will be moving either right or up, depending on your orientation and the situation. If the velocity is more than zero, it'll be moving left or down, or maybe backwards if the velocity is less than zero. It'll be stationary, in other words, motionless, if the velocity is equal to zero. It'll be speeding up if the speed is increasing. That is, if the absolute value of the velocity is increasing. Another way to look at it is if the velocity and the acceleration are both positive or both negative. That means if you're say going to the right and the acceleration and it's positive, which means it's positive, and the acceleration is positive, then you are speeding up. If you're going to the left and the acceleration is negative, you're also speeding up. You're going faster to the left. Now you're slowing down if the speed is decreasing, looking at, say, the graph, or V and A have opposite signs. The other thing we'll be looking at is what is the longest distance the object has from the origin. And it'll occur when the first derivative of the position is zero, or it could occur at an endpoint. Now we're going to look at this as we work this problem. Now the problem, we're given the position where the S is a polynomial of third degree, and we're looking at it between t equals 0 and 4, and it wants us to calculate the velocity and the acceleration. Well, right here we have the velocity as the first derivative of the position, and you already know the power rule for polynomials, so that would be 3t squared minus 12t plus 7. So that's the answer to the velocity. And then the acceleration is the first derivative of the velocity, which is 6t minus 12, taking the derivative of each of the components here. And of course, the derivative of 7 is 0. Then it asks you to choose the correct graph of the position and the velocity and the acceleration. And you put this in your calculator, and I'm going to show you a blown up view of this that I graphed. But the answer here in this particular case is A. Just look carefully and see the position of each graph. Like here's the acceleration, here's the velocity, and here's the position. And I did a graph of this. And then I'm going to very briefly show you some of the things that you would have to do in order to answer some of the other questions. So here is, first of all, the position. given right here in sort of a tan color. The velocity is in blue, and the acceleration is in green. It's a straight line. Now, you remember we said the position, the object is stationary or not moving when the velocity is zero. So one of the things we pointed out is, when is the velocity zero? And I'm going to show you how we calculate that in a second. But the answer for these two coordinates is 6 minus the square root of 15 over 3, and 6 plus the square root of 15 over 3. Then I'm going to look at this same graph, except with the velocity. I'm going to take the absolute value of the velocity, and that will flip the negative part to positive. And so the dark black curve here is the speed, which is the absolute value of velocity. And you can obviously see where it's slowing down. It's slowing down here also, slowing down. And then let me say take a red color and show that here it's speeding up, and it's speeding up here. So now, knowing these coordinates, we can answer some of the questions about the speed and other things. So now we'll be referring back to the questions. The first question is, the object is at rest. The object is at rest where? And we need to find the zeros of the velocity function. And the velocity, of course, is a quadratic. And we want to find out when it's equal to 0. So we solve with the quadratic formula. And you remember the quadratic formula given here. The A is 3, the B is minus 12, the C is 7. And so plugging in, we get this equation. And finally, we get T is 12 plus or minus the square root of 60 divided by 6. Now notice that 60 is equal to 4 times 15. So you can simplify the quadratic. And the simplified solution to this is given by 6 plus or minus the square root of 15 over 3. Now notice the answer I put in here was the unsimplified form, which is still the same value, but I also put here the 2 points where it's stationary. Sometimes my math lab will not accept an unsimplified form. So anyway, we know where the object is at rest. That's when V is equal to 0, and we calculated the coordinates. Then when does the object move to the left or to the right? And the first thing we realize is the object is moving to the left, which means it's going down. During the time the velocity is negative. Going back to the curve here, the velocity is negative between these two points that we just calculated. 6 minus the square root of 15 over 3, and 6 plus the square root of 15 over 3. So the velocity is negative. And which means it's moving down or to the left over this interval. And the object is moving to the right or up when the velocity is positive. And that is between 0 and 6 minus the square root of 6 over 3. And also there is another area between 6 plus the square root of 6 over 3 and 4. And so that's a union of those two intervals. Now, when does the object change direction? It changes direction when v goes from plus to minus, or from minus to plus. And that happens to be exactly at these zeros of the quadratic. So there's the answer there. Now we're asking when does it speed up and when does it slow down? And we will answer that by going back to the curve again, looking at the speed. It's slowing down here and it's slowing down here. So it's would be from 0 to 6 minus the square root of 15 over 3, slowing down from 2 to 6 plus the square root of 15 over 3, and then it's speeding up in the other two intervals. So just referring to that, it speeds up over two different intervals. From 6 minus the square root of 15 over 3 to 2, union with 6 plus the square root of 15 over 3 up to 4. And as we saw, it was slowing down from 0 to the first point where the velocity crosses the 0 point, which is 6 minus the square root of 15 over 3. And then from 2 to 6 plus the square root of 15 over 3. Just go back and look at the curve and you will agree that those are the points. Finally, it asks, when is the object moving the fastest? That means the highest speed. And if you go back and look at the speed, you'll see it's the fastest at this point and at that point where the speed is 7. So at 0 and 7 and at 4 and 7, it is the fastest. And the other question will be when it is at the slowest. Obviously, it'll be at these points where the velocity is 0. In other words, it's not going anywhere. It's at 0 velocity. So it's at fastest, as we said, at 0 and 4, where the speed is 7, and it's slowest at these 2 points where the speed, as we saw, was 0. Now, when is the object the farthest from the origin? Well, there we need to look at the position graph. We can look at either one of these. But looking at the tan position graph, the farthest where S is the largest is right here. Notice that point is where S prime equals 0, and that corresponds to the 0 for the velocity function. Obviously, the velocity is a derivative of the position, and that point is given here, 6 plus the square root of 15 over 3. And now we can finish up the problem. It's farthest at this point, and then we calculate how far it is, and just plug into S equal T cubed minus 6T squared plus 7T, and just plug this in, and you'll see that it's 6.303. So that is the problem we're talking about.